In this podcast, we're going to investigate empirical formulas, specifically how to do them the stoichiometry way. All right, so here we see, let's remind ourselves of what an empirical formula is. An empirical formula is the lowest whole number ratio of the elements in a compound, whereas the molecular is what it appears like in nature. So here we see molecular P4O10. We see that 4 and 10 are both can be reduced by 2. So we divide both of them by 2 and you get P2O5, lowest whole number ratio. H2O, you have coefficient or subscripts of 2 and 1, cannot be further reduced. So the empirical and molecular are the same. N2O4, both can be reduced by 2, so that gives you NO2. Down here you see another example of the same type of thing. CH4, that would be methane. That is the empirical formula. And then C2H6, that would be a different formula, but that is a molecular formula. It's not an empirical formula. Okay, so if you were to reduce this, you would get CH3. Okay, so molecular, not completely reduced, empirical, completely reduced. Okay, so we're looking for the completely reduced one. There are a couple steps that you can use when trying to find an empirical formula through stoichiometry. First, you want to take the amounts that you're given and convert them to moles of the original component atoms in the empirical formula. That's going to be the stoichiometry. That's where that comes in. And then the last two steps are steps you're familiar with, which are dividing each by the smallest number of moles once you get to that part. And then you're going to multiply to get whole numbers if when you divided that didn't give you whole numbers. Okay, so let's look at an example problem. All right, let me erase this real quick. All right, so we have this example problem. Tells us we have silicon and hydrogen, SiXHY, so X and Y are representing the subscripts that we're going to try to find. And it tells us we have a 6.22 gram sample of this. Okay, so let's go ahead and start writing down some data to help us in solving the problem. So we have this CiXHY, and we have 6.22 grams of it. All right, and then it tells us that we burn it in oxygen. So we react it with oxygen. So we're going to need to write a balanced chemical equation here. Okay, so O2 is the formula for oxygen. And it tells us that when we do this, all of the Si is converted into SiO2. Okay, which is 11.64 grams. That's how much we made. Okay, and then it tells us all the H is converted to H2O. All right, and that'd be 6.980 grams. All right, and then wants us to determine the empirical formula. All right, so we have our basic information written down. We want to take these, the known amounts that we produced, and try to bring them back to just Si and H respectively. Okay, so we're going to take this 11.64 grams of SiO2, and we're going to use stoichiometry to get it back to just Si. Okay, so first we've got to get it out of grams. So we need the molar mass of SiO2. Well, after I calculated it up for us, I got 60.09. Okay, so that's your molar mass of SiO2, and that's equal to 1 mole of SiO2. Okay, that cancels those out, but we still got to get to grams of Si. Okay, well, we know that for every 1 mole SiO2, there's only 1 mole of Si in that. Okay, because there's a imaginary 1 subscript right there. Okay, All right, and then we're going to calculate that out, and that's going to tell us our moles of Si. We got 0.194. Okay, now we want to go back and we want to do the same process, but we're going to do just hydrogen this time. Okay, so we're going to do 6.98 grams of H2O. All right, and now we're going to do the same process using stoichiometry. So first we got to get it out of grams. So we're going to put molar mass on bottom. There's our molar mass of H2O. And that's 1 mole of H2O. That's what that's equal to. So our grams went away. All right, and now let's get that from H2O to just H. So we know for every 1 mole of H2O, we have 2 moles of H. Okay, because that little subscript 2 there. Okay, then we're going to multiply and divide, and that gives us 0.775. Okay, now after you're here, you're done with the stoichiometry part. Now it's just an empirical formula problem. So you're going to divide both by the smallest number, which is 0.194. Gives us 1 there. And then divide this one by 0.194. All right, and that gives us 4. Okay, so that tells us that our empirical formula for our SiH compound is SiH4. Okay, and that's what we were looking for.